Hello, this is a tutorial video about dichotomous moderator moderating relationship between two continuous variables. And I'm Jan, and I'm trying to making these videos for myself and for you who may need it. And this is our objectives. And I'm making this is to understand moderation effect with example. And we have example about dichotomous moderator in this specific example we will see, and we will also see how we put this example in Mplus, and we will show some of this code and show how we will understand the result, etc. And there will be two ways we are going to examine the moderation effect specifically. One is to examine the beta 3 if it's significantly different from 0 directly. And another way is to examine the nested model, see if this full model is significantly better than the restricted model without the moderation effect. All right, let's continue. Okay, I am going to show you my model. Here's my model. I have two constructs, family practices and character development. And in my model, family practices is predicting character development. And I'm looking to see if school location type moderate this effect from family practices to character development. Okay, and my school location type includes urban school and rural school. Therefore, it's dichotomous variable. Okay, all right. In this page, I'm going to show you the prediction model for character development. And the highlighted part is the prediction model in general. That includes, if we read this, that will be character development predicted by family practices and school location type, and the interaction between family practices and school location type. Because school location type in this case is dichotomous variable, usually we treat this dichotomous variable in this moderation effect as dummy variable, which is only includes only zeros and ones. And in this case, we coded urban schools as 0 and rural schools as 1. And we will take a look at this prediction effect from two location types separately. And first, we will take a look from location type urban, and we will see how this character development is predicted. As we see that urban school is coded as 0, therefore, when we plug in the location type as value 0, we will see that both this term beta 2 times the location type and this term beta 3 times location type times family practices, and this two term will become 0. Therefore, the prediction model for urban schools can be simplified as this one highlighted here. And at the same time, if we take a look the prediction model for urban schools, we will plug in the code for rural school as 1. So if we plug in 1 for location type from the general prediction model, and we will end up with this simplified model here. So we will have character equals beta 0 plus beta 2 plus beta 1 plus beta 3 times family practices and plus the randomness. So what does that tell us? That tells us when we take a look at these two models from different area, we will see this difference in terms of their intercepts. and their slopes. And specifically, slopes is the one that cause the difference between this relationship of family practice and character development. Therefore, when we are examining this moderation effect, one way we can do is we can examine if this slope here, beta 1 plus beta 3, is significantly different from this slope here, beta 1. How we are going to examine is we are going to specifically to find the difference between these two slopes, which is beta 3. And we will see if beta 3 is significantly different from 0 or not. All right, let's take a look at this example in the Mplus. Okay, in this example, I'm going to show you all the way above here. Okay, and these are just a title file, variable, and these are the basic information missing. Use variable grouping, and grouping is the one that is closely related to. We will need to define the moderator, which is the grouping variable in this case. And we also need to define our model based on what we've seen at the beginning. And in this case, character development, this is our one of our constructs defined by all these items here. And this is a family practices construct, and this is consisted of all these items here, and this is the relationship. Okay, what we are going to do now is we're going to compare the code and the model. How we're going to define this from our code is to label these intercepts and these slopes. And if we take a look at model urban, which is the same as this part, we will see that we have made the slope, the intercept of this model as 1, which is B0, G0, and for rural as another one, B0, G1. This, whatever you put here, it doesn't matter. As long as they are different, that means the labels are different. That refers to there are different intercepts in this case. And we also take a look the slope. As we see, the slopes are also labeled differently. And let's take a look at model constraint. When we do this, we will create new variable. Here is B3. And what B3 is the difference between the two slopes. And our goal, like we explained before, is to see if this B3 is significantly different from 0 or not. And this plot, tab equals plot 2, is to show us the bootstrap plots for these different models, model rural, model urban. We won't be able to see the plot here because I don't have the graph ready, but you will see it once you run this. Okay, I'm going to show you the B3, and we will take a look at the result of B3 so that, and this is where we can take a look. And the B3, as we see, it's estimated as 0.157, and the p-value associated to that is 0.028. What does this tell us is that this B3 is indeed significantly different from 0. Okay, this is one way to check the moderation effect. And there's another way, which is to examine the nested model. And what we are going to show here is we will show these two models. In this full model, we will have, or we will include all of these terms related to this relationship that we are examining. Therefore, we have predictors from family, location type, and the interaction between family and location type, as we've shown at the beginning. However, the restricted model is where we do not have this interaction term between family practices and location type. Therefore, the restricted model can be written as this model here. So what we are going to do is we are going to examine the model fit, and for each case, for the full model, for the restricted model, and we will examine if one model fits significantly better than the other one. Okay, so let's take a look at this in code. And this is the full model. This is our result, and if we scroll up, we will see the code there. Basically, everything else except for the model part, it's the same with the first example we showed. In the model part, the model urban, model rural here, we will have different intercept and different slope. So intercepts are different and slopes are different. This is the full model. On the other hand, the restricted model, we have the slopes the same. You will see that. We have the slopes. We define the slopes the same intentionally. And then what we will do is we will examine the model fit. Basically, you will go to your model fit index here, and we will examine the chi-square. So we will examine the chi-square difference between these two models. And here we have chi-square test model fit for the restricted model here. And value and degrees of freedom, we will record them. And then I'm going to show you here that these are the ones that I've recorded from the result. And for the restricted model, we have chi-square value of this and degrees of freedom of this. And full model, we have chi-square of 224 and degrees of freedom of 150. And then we will examine the delta chi-square, and we will find the delta degrees of freedom. And then we will see if these two models are significantly different from each other by examining the which we call the delta chi-square delta degrees of freedom, which we also call that as a likelihood ratio test, and see if it's significantly different from each other. And in our result, as it's showing here, is indeed significantly different from each other. And this is this actually confirmed the other way, and it should be, because these are just different ways to examine, and they are basically the same. Okay, so what does that tell us is that we know this moderation effect is indeed significant. Therefore, the urban and the rural will have different effect from family practices to character development. And we will take a look at this. How you are going to examine is you can actually examine this effect from either from this one, from the full model, or from the model at the beginning. You will be able to see the effect. For example, in this case, this is the example to examine beta 3 is significantly different from 0 or not. And we will see that in this example, among urban schools, we have family practices predict the character development by a beta efficient with 0.35, and in rural schools it's 0.598. And yeah, in addition to this, like we talked about, you will see a graph, the bootstrap graph, with the 95% confidence interval there. Yeah, and that tells us how to examine this moderation effect for dichotomous variables. Thank you.